Today I want to share share with you some of our projects and activities on network resilience, right? That I think could be synergetic and or establish grounds for collaboration with some of the partners here. You go? Yeah. But network resilience, right, can mean different people, different things to different people. It really depends on who you ask. So to set the stage, I want to state that we're using the definition of network resilience from the Next Alliance as the capacity of a communication infrastructure to extend and adapt to diverse disruptions, both intentional and unintentional, ensuring continuous service availability. Or how I like to think about it, imagine mobile networks like Rocky Balboa, right? Taking punches and standing up, but if you're falling down, recover and get back up, right?
It's a very old reference.
People don't know.
You guys know. But yeah. So, and at CCI, we are linking network resilience to two different projects that look at this through different angles, but that yet complementary, both at the infrastructure and topology of the network, but also at the control management. On top of that, I have a bonus. I'm also going to talk about some of our overall training and workforce development activities that I think will be of interest to some of our industry partners. For starters, we're taking different spin to resource management, right? Looking at resilience, because you all know, like mobile networks have a bunch of different options to tackle and recover from disruptions and attacks and problems, right? But all those strategies generally involve over-provisioning resources or dynamically relocating your network to accommodate to recover from an attack. All of which work, right, and serves to create different redundancies in your network. But there's a limit to how much your network can recover to different attacks, right? Going back to Richard's presentation, right, there's always going to be an upper bound. And the kind of question that we're asking this project is, okay, but when rigid boundary, right, what can you do? What can go beyond that to still ensure we have our own operational network? It can be crappy in terms of performance, right, but that can still work. And for this, we're exploring the concept of network fungibility, or rather, fungibility actually comes from finances, right? You think about gold or diamonds and dollars, right? They're very different things, they serve different purposes, but if you're looking at just a building wealth or just having a value, they are all interchangeable, right? And you're trying to adopt the same kind of notion to mobile networks by exploring different resources, functions, and components that can be used and replaced interchangeably, right, to do the same task. One of the things we did in one of our previous works was actually to explore trade-offs between spectrum and the density of your network. And we're able to demonstrate that they're basically interchangeable and can be replaced to achieve a certain reliability. And we're able to extend this notion of fungibility to all the types of resources, all the types of functions and technologies to create new equivalences in your network, right? Creating a new degree of freedom for resource management so as to withstand and recover from failures and attacks. But what I want to talk today about is this project with, actually just a project with Ireland. It is the result of international collaboration with Queen's University of Belfast and Trinity College, our friend Nicola. So then you're going to see me around for a while. But the thing I want to talk to you guys today was our view on network topology, right? Because we're exploring different network topologies and boundary splits, leveraging the ORAN framework, right? We want to use and explore ORAN's monitoring and orchestration capabilities for improving the performance and activity of network functions, but also different network sites, so as to create different types of orchestration policies and AI-based resource reallocation strategy. And use this to train different AI-based orchestration policies. And as part of those efforts, we want to create a demonstrator, an end-to-end platform, right, that allows us to demonstrate this idea of this adaptive system that recognizes that certain functions or all clouds are dead and find the best strategy to relocate resources and recompose your network, be it changing function split, right, going from monolithic ODU or compose or separate, and so on and so forth. Changing gears a little bit, I'll talk about conflict conflict detection, right? Going back to kind of the conversation we had, Mary. We talked a little bit today about different accepts and all the amazing things they can do in terms of management of network and innovation, the conflicts they do, and they're different and have different purposes, which is great. However, they can and will conflict one another, right? You can have some accepts that want to save energy in your network, while others want to maximize throughput, right? And this can lead to erratic behavior, anomalies, a bunch of problems, like outlined in a pacifist paper, also going back to Richard's presentation. And sadly, so far, there are no existing mechanisms or strategies to detect and prevent those conflicts, right? So right now, we have some preliminary works that look and model the conflicts and relationships between accepts parameters and the performance metrics they eventually influence, right? So the Viriginia graphs, which are great, are amazing. But and by analyzing the topology of those graphs, we can infer and identify different types of conflicts and who is causing what. But existing works, right, they assume that all this information is known or can be captured in the lab, so on and so forth, right? We think that half of it is true, because then again, the relationship between the accepts and control parameters, it's trivial to identify. But how the different parameters influence performance metrics can change over time and space, and they're non-trivial and very complex, right? And we have an hypothesis that we think we can learn from these complexities, right? Or we can learn the complex relationships between the parameters of psychometrics so as to reconstruct the missing bottom part of those heterogeneous conflict graphs. And yeah, and right now we have some preliminary results using GNNs and graph neural networks, and this is the result of a new project we got with new seed project we got at the Idaho National Laboratory, and we're going to spend the next couple of years exploring extensions and evolutions of this, including prototypes in a real system. Moving back. The last thing to talk to you guys today is about our training and workforce development activities in ORA. Because then again, ORA is great, amazing, going to make mobile networks interoperable, softwareized, program and open, which is all great, but like every new technology, there's a steep learning curve, right? We're talking about new components in software and a bunch of different things that mobile operators, especially the small ones, lack know-how and expertise, right? And I don't want to criticize the ORA Alliance that much, but the recommendation is horrible. If you have ever tried to build anything by yourself, you know it's going to be very, 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 very painful, right? Which means it's going to take you time, which means it's going to cost you money, right? To tackle this, we authored the first accept development tutorial ever. It's extremely comprehensive. It covers everything you can imagine, from the theory, the practice of RMR, messaging, SDSL, each service models, you name it. We have both the theory and also a bazillion different code snippets using the Python framework. Again, it's enormous. And we also have an accompanying GitHub repository of our examples and tutorials, and it has everything, right? And this was the result of a collaboration of the Open RAN Brazil project, funded by the Brazilian Ministry of Science. And on top of that, based on this tutorial paper and exploiting our theoretical abilities that we have at CCI, we also prepared a 2-day-long workshop, right, for industry members who are interested, providing comprehensive tutorials and hands-on experimentation at the CCI actually test bed that presented earlier. And if you're interested, here's a link. We would be really interested to hear from you. And that's it.
Questions? 2, 3,
Okay.
4. Where can I find the GitHub repo?
Oh, it's on our paper. If you actually search for, wait, I'll go back. If you search for Google Scholar, so sorry for the self-promotion. If you search for Google Scholar for managing our networks from 0 to hero, Google Scholar, we always don't be like the first or second result. And in the archive paper, there's a link to our GitHub. But also, if you just search for the same name, managing our networks, the accept development from 0 to hero on Google should also put you, yeah, perfect.
Other questions? Looks like that's going to be a required reading.
I swear, it's like 39 pages of pure fun.
It's beach reading.